Before you watch this video, you may want to refresh your memory on setting up the SOHCAHTOA fractions, and you also need to be aware of how we draw angles on the coordinate plane. Both of those videos should be linked in the top right corner of this video. Okay, so when we set up our SOHCAHTOA fractions in the past, we haven't been on the coordinate plane at all. So we have just drawn a triangle, labeled our sides, opposite, adjacent, hypotenuse, used SOHCAHTOA to label some numbers, use the Pythagorean theorem to find the third side, and then set up our SOHCAHTOA fractions. In the past, it hasn't really mattered how you draw your triangle. This time, it is very important that you draw your triangle against the x-axis. Anytime you have any triangles or any sign values or anything that mentions the coordinate plane, draw your triangle against the x-axis no matter which quadrant we're in. When you label your sides, the adjacent side is always going to be the x-axis. That's really important. And the hypotenuse is always the terminal side or the slanted side of our angle. If the problem gives you a sine, cosine, or tangent value, then use SOHCAHTOA to label two sides of your triangle. Or if the problem gives you a coordinate point, then you'll use x and y coordinates to label the adjacent side, the x, and the opposite side would be the y. Then, just like before, use Pythagorean theorem to determine the third side. When we're on the coordinate plane, we have positive and negative signs. When I'm doing this step, I ignore all negatives. Only use positive numbers here so you do avoid a careless mistake. But once you have your third side figured out, you want to double check your signs based on the orientation of your triangle. The hypotenuse is always going to be positive. The adjacent and opposite sides will follow the signs of the x and y axes, respectively. Finally, just like before, set up your SOHCAHTOA and reciprocal fractions. Your homework may not require you to rationalize denominators, but I will. Let's do some examples. I have a handful of examples to do in this video, and they're all worded just a little bit differently, but they're all asking you to do the same thing. Draw your triangle against the x-axis, label all your sides, find your third side, set up your SOHCAHTOA fractions. That's all we're going to do, these same steps over and over and over. Determine the 6 trigonometric function values for the angle shown. All right, so let's do triangles like we've done before. I need to draw my triangle against the x-axis. So here's my slanted side. That means I want to draw my triangle down here against the x-axis. There's my triangle. And even though my theta technically is this angle out here, I'm going to use, this is called your reference angle against the x-axis. I'm going to use that and it'll work out perfectly just like normal. Okay. Step 2, label your sides, opposite, adjacent, hypotenuse. So you always put your triangle against the x-axis and your theta or your angle against the x-axis. This terminal side is always your hypotenuse. Because theta is against the x-axis, that means my adjacent side is always the x-axis. And across from theta is this opposite side. All right, step 3, use your SOHCAHTOA or your coordinate point to label numbers here. Remember, coordinate points are written x, y. So that's telling me my adjacent side is on the x-axis. It is square root 7. My opposite side is parallel to the y-axis, so its length is -3. Step 4, use the Pythagorean theorem to find the third side. I know that I have a -3 here for the opposite side, but I am going to use all positive values. So I will have square root 7 squared plus, I'm just going to use a 3 instead of a -3. And you should be able to solve this yourself. Step 4, double check your signs. The hypotenuse is always positive. And then the adjacent, this is the positive x direction, this is the negative y direction. That is why I have a positive square root 7 and a -3. Finally, we have our triangle set up, so now we just have to find our 6 fractions, the SOHCAHTOA and their reciprocals. I want you to rationalize any denominators you have. All right, sine theta equals opposite over hypotenuse. Duh. done. Cosine theta equals adjacent over hypotenuse. And tan theta equals opposite over adjacent. Make sure you rationalize your denominator. Okay, let's use reciprocals to find the other three values. Cosecant is the reciprocal of sine. Secant is the reciprocal of cosine. Rationalize your denominator. And cotangent is the reciprocal of tangent. I'm going to use the original tangent fraction before we rationalized. And we're done. That's it. So draw your triangle against the x-axis, so theta is against the x-axis. Label all your sides opposite, adjacent, hypotenuse. Use the coordinate point to figure out your numbers. What's this called? Pythagorean theorem to find your third side. Double check your signs, and then set up your SOHCAHTOA fractions. It seems like a lot of steps, and it is, but we've been doing this, so it's not too new, hopefully. Let's do another example. Wording is going to be different here. Given that cosine beta equals -4/5 in quadrant 2, find secant beta, sine beta, and tangent beta. Okay, let's draw a picture. It matters how you orient your triangle. Remember, quadrant 1, 2, 3, 4. My triangle will be in this quadrant, and I need to draw it against the x-axis. So beta will be against the x-axis, or reference beta. All right, label your sides. The hypotenuse is always the slanted side. The adjacent side is always the x-axis because it is beside where we put our angle, and we always put our angle against the x-axis. And the opposite side is here. So SOHCAHTOA, this time we're given a cosine fraction, so I know my adjacent is 4 and my hypotenuse is 5. I want to make a comment here before I deal with my negatives. Just because that negative was on top doesn't mean the 4 is the negative number. Generally speaking, people usually write the negative on top or they write the negative out front. But technically, your negative could be with the 4, the 5, or just in general. All three of these ways of writing this fraction all mean the exact same thing. It doesn't really matter where your negative is, on top, on bottom, or out front. It just means I have a negative fraction. So I can't just assume that negative goes with the 4. We're going to wait and deal with that after we do Pythagorean theorem when I check all my signs. So deal with the negative last. Let's go on and do Pythagorean theorem to figure out what our third side is. You should be able to do this on your own. Okay. Now we need to double check our signs, or actually do our signs. The hypotenuse is always positive, and then use your axes here to label opposite and adjacent. So this is the negative x direction, so my adjacent, which is on the x-axis, is negative. This is the positive y direction, so my opposite is positive. Now I can set up my fractions. Secant is the reciprocal of cosine, so I didn't even need a fraction. I didn't even need a triangle here. I could have just flipped my cosine fraction. And you can put the negative with the 4, with the 5, or out front. Sine. Sine is opposite over hypotenuse, and tangent is opposite over adjacent. And again, it doesn't matter where you put the negative, with the 3, with the 4, or just out front. Let's keep going and do another example. Again, it's completely worded differently. Let -2 square root 3, comma -4 be a point on the terminal side of theta. Find the exact value of sine theta, cosine theta, and cotangent theta. Okay, it matters how you draw your triangle. And this one's not as straightforward as the last example where they told us we were in quadrant 2, or the first example where it drew it for us. You have to look at your signs here to figure out where your triangle should be drawn. negative x, negative y, negative x, negative y. So that means that's somewhere down here in the third quadrant. Draw the triangle against the x-axis and put theta against the x-axis. Label your sides. The adjacent is always the x-axis. The hypotenuse is the slanted side. And then use your coordinate point to label your sides. Adjacent is the x-axis, so the x part of the coordinate point goes here. And the opposite side is parallel to the y-axis, so the y piece will go there. Use the Pythagorean theorem to find the third side. I'm going to use all positive values here just so I can avoid careless mistakes. 2 squared times square root 3 squared is 12. Make sure you break down your third side, your square root. So if you can pull out a pair of 2's like I can here, pull it out. And then double check your signs. We're in the negative x direction, the negative y direction, and the hypotenuse is always positive. Final step. Set up your SOHCAHTOA fractions and reciprocals. We need to find sine theta, rationalize the denominator, and simplify. You could have simplified 4 over 2. On the first step, I just waited to do it at the end. Cosine theta, set up your cosine fraction. You can rationalize the 7 or go on and cancel out these 2's. And now rationalize the 7. This one was a very intense problem. And then cotan theta, I have to set up my tangent fraction first, opposite over adjacent, and then flip that to come up with my cotangent fraction. And it's a double negative makes it positive, and I can simplify to make this 1/2.